All right. All right, we're talking about unit testing. Review from last class. All right, multi-select. Why are unit tests important? Okay, yeah, great job, everybody. All three of those are true. We didn't talk about the automation portion a ton, but just the fact that every time you push your code through, and it gets compiled and, put into the main part of the code, if those tests are running every single time that happens, you don't have to do it manually. So it's a huge deal. Okay. Brad is in the lead. All right, true, false. JUnit is an external library that has to be installed as a dependency within your Java application. True. Yep. Yeah, your book actually walks you through the steps of how to do that. So that is absolutely true. All right, Brad's still in the lead. Quiz, multi-select. What are characteristics of good tests? Great. Yeah. Deterministic, I realize is probably the one that's the hardest to remember exactly what that means. It means that the tests are stable. They work every single time as intended. They're not flaky. And of course, relevant. Yeah, you want your code to be testing the most important parts of your code. You don't have to worry about getters and setters and things like that. And meaningful. They really do need to, represent exactly what they are intended to truly test the code. And then alliterative was just a joke because of the AAAs. Okay. Vengeance is in the lead. All right. Puzzle. Put the AAA pattern in the right order. Great. So let's talk about this. Arrange is first. That's arranging variables. Maybe you're instantiating an object of your class. You have some sort of expected value that you're, going to have a variable for perhaps. And then you act on any methods. You call something that runs the code. It actually taps into the class itself and does that. And then you make the assertion, is this thing equal to this other thing? Or is this thing true? Or is this thing false? So arrange, act, assert. Maple's in the lead. All right, true or false? The AtBefore annotation tells the compiler that a method is a JUnit test. False. Yeah. AtBefore is for any code you want to run before each test, but the annotation that you want for the test itself would be @test. All right, NW in the lead. Which is not a valid assertion method in JUnit? Yeah, good job. So assert not equal is not a real assertion method, but assert not null is. Okay, true or false? Using the alternate constructor with a message parameter in your assertion method improves documentation and fail logs. True. Yeah, you guys saw me demonstrate this a lot. I modeled this for you because I think it's important. You can use these assertion methods, assert true, assert equals, with the very first parameter actually being a string that has a specification, message, some sort of statement that says this is what this test is supposed to be doing. And it's much, much better when you have failures on the test and also just for documentation purposes. Okay, last question. Multiselect. Which are not valid ways to import assertion methods? Okay, so these two are not correct because for the first one, the red triangle, you have to have that assert class in there. You have to have, any import statement, you have to access first the package and then the class, and then you can, specify a method if you want. So the green square is course correct, where you have, org.junit.assert true. For the blue one, it's not enough to just do the class. You have to at least represent the methods. So that's why the yellow circle with that asterisk is also fine. And that's a great way to do it if you're planning on using multiple assertion methods, because it'll just pull them all in at once. All right, great job. Let's see how we did. All right, in third place. Second place is Maple. Great job. First place, NW. Our momentum goes to Ian and Brad. Great job, guys. Okay. All right, let's move on. Well, let me see. Is Colin here? He is not. Okay, I will cover his stuff when we get to the announcement slide in a second here. Okay, so we're talking about inheritance tonight. We've been talking about classes. We did some unit testing, and now we're going to focus on class stuff itself again. Typical class format tonight. Announcements. There will be a catch-up class on Thursday the 9th, and Colin is going to do a short Q&A at the beginning about liftoff prior to you splitting into your studios for your work. And then the deadline for graded assignment 2 will be on Monday the 13th. In the meantime, with a graded assignment 1 being due today, Colin is going to be sure to follow up with those of you who have not turned it in, just to make sure you're on track and see what you need, if you need any help kind of doing any sort of catch-up plan or anything like that. And I feel like there was something else he was going to say. I'm not sure. I think, I know. He said that he was at what was the event the other night?
Code Till Dawn.
Code Till Dawn, yes. And he was glad to have seen some of you. So yeah, that's awesome. Okay. So inheritance, we are talking about classes created from other classes. This topic is not new to you because we did discuss it in the JavaScript unit. But we are going to look at it from a Java point of view. And as you can imagine, it's a little more involved. Okay, so we'll talk about some terminology, look at some specific syntax with Java. We'll talk about abstraction and how and when you would want to designate an abstract class and an abstract method. Talk about unit testing with subclasses, and then diagramming classes, which is something that you will be doing for Studio tonight. So let's get into this. Okay, so inheritance terminology. There's lots of different ways to talk about this, but it's all the same concept. We call it inheritance. Sometimes you'll hear it called subclassing. And we've talked about it in the JavaScript unit in terms of parent and child classes, right? We even sometimes talked about a grandparent class, if you have multiple levels of inheritance. But you'll often hear this called parent called a base class or a superclass. And a child class is also called a derived class or a subclass. Tonight, I'm probably going to be referring to mostly as base class and subclass. But we have this, kind of general example that we're going to dig into tonight. And you've seen a version of this before. But, you have this kind of parent, base class beverage. And from that, you can create all of these subclasses, water, juice, soda. And then soda itself can become a base class by having a subclass, diet soda. So we're going to kind of go through some examples. And of course, we'll do a whole lot of live coding. So I'm going to kind of, get through these slides first, and then we'll jump into the live coding and put it all together. So with Java, the syntax is somewhat similar to JavaScript. Initially, you want to use that extends keyword to make sure that all of the fields and properties and methods are passed from the base class to the subclass. And subclass can inherit from only one other class, but it can also be a base class for another subclass, as you can see. So, this keyword extends is used. In this case, we're creating soda as an extension of beverage, and we're creating diet soda as an extension of soda. So here we have a base class beverage, and then its subclass is soda, but soda is also a base class because its subclass is diet soda. Is that clear? Okay, so more on syntax, let's talk about constructors. If you want the subclass to be able to use the base class's constructor, it will be implicitly called if it has no parameters. So, in Java, you can have a default constructor that you don't have to code. It's just there behind the scenes, right? As long as you don't have any parameters. So if that's the case, then your subclass can just, inherit that implicitly. But if you have a constructor that is, not a default in your base class, then your subclass is going to need one as well. And then you'll need to use that super keyword to call it from inside the other constructor, and then give it whatever arguments are required by the original constructor in the base class. So let's look at this example here. We've got beverage. The parameters are name, ounces, and container. And you can also see we've got an ID thing going on there that has nothing to do with, those parameters. That's fine. Soda inherits all of that when we extend beverage. But we also have a new field here for soda that is caffeinated. It's a Boolean. And so we want to require not only the first three, but also that one. So first we call super to pass along name, ounces, and container to the original constructor up in beverage. And then we also assign caffeinated to the field that is stored, with this class that doesn't exist in beverage. So you can kind of combine them that way to make it work. But yeah, that super keyword is super useful, haha, so to speak. All right. And as far as modifying behavior, if you've got methods are, automatically inherited, but you may want to override them. So you can use this override annotation. We looked at this before with, customizing toString. But it's very important if you are working with multiple classes and inheritance, because you want to make sure that it knows exactly which one it's supposed to use. So, in this case, we have, this soda class that has name, ounces, container. It has caffeinated. We've added a toString method that's overriding it. So we've used that override annotation. And then you'll notice that in order to access the values of the other fields that are not actually declared in this class, because they were declared in the parent class beverage, we just use the super keyword down here and say, and use the getters, right? So I have, return super.getOunces, super.getContainer, and super.getName. And then I get my caffeine text here, which is, I've used a little ternary expression here to decide whether to add the words with caffeine or not, depending on whether is caffeinated comes back true. That's our getter locally here. And then I have added on the ID at the end, and I've used super again because ID is another thing that exists in beverage, not in soda class. So this is very common way to put things together and make good use of all of the fields that belong to it by combining the ones that were inherited with the ones that were actually declared just as a part of this class. Okay, now let's talk about abstraction. You can actually have a class that never has objects instantiated from it. It's just meant to be a base class so that other classes can be created from it with using inheritance, and then they would have the objects done. And you use this abstract keyword to designate it. So when you actually, define the class, you'll say, public abstract class beverage. And then you can also apply the abstract keyword to certain methods if you want them to force each of the subclasses to define it. And the key here is that you have to make sure that you don't define it in the abstract. Like, it won't let you. IntelliJ will not let you. If you put abstract on it, it's going to complain at you if you try to actually have some brackets, there and try to give it some sort of definition. So you just put say what it is, give it a name, and then put a semicolon on the end. And as long as it's got that abstract on it, then every single subclass that's created and with inheritance from beverage will be required to have a toString, and that's where you actually give it the definition. And we are going to do this, so you will see it in action. And it's an interesting to choose to do toString this way is especially interesting to me because toString already exists on the object class, and every class has it by default. So what we're really doing here is saying we want, not only do we want all of the subclasses of beverage to have custom toString, we want to make sure that they're not going to have the default one. So we're going to override this here and give it absolutely no definition so that all of the subclasses will have to do it. and it will never use the, crazy default one where it tells you where it is in storage, which isn't helpful. Okay. Last little thing to touch on here before we talk about diagramming is testing. And really all there is to say about this is, there's nothing new to learn about how to write the test. It's just more to say you want to verify your inheritance. This is a great way to do it. So you can create a couple of objects of the subclass, which in this case would be soda, and then, write some tests to verify that the fields that belong to the parent class actually do get set the way that you expect them to, because you've called super from the constructor. And so this is one example of that test, and we'll code some of that out too. All right. Last concept here is about diagramming classes. And I've worked out my way to the end of the planning, like backwards to planning. So what we're going to do is talk about this, and then we're going to go and work our ways back the other direction and actually do some coding. So there's this convention out there, UML, Unified Modeling Language, which is a good, widely accepted one to use. And so that's kind of what the convention I'm using here. You plan out a class by giving it a name, and then you list the fields, and then you list its methods last. So these are usually kind of done in 3 different sections. And you use the plus sign for public fields and methods, and minus for private. So you can see here, I've kind of set all of these, fields as private, and then set the constructor and the getters and setters and the custom toString method all as public. Underlined name if it should be static. So next ID is one of those ones that we want to store at the class level, not at the instance level. So I've underlined that. Use a colon after the name of each thing to indicate the type. You see, I've done that with everything. Use italics if something is abstract. So you'll notice that beverage is in italics and toString down here is in italics. And then if you're planning a subclass, you don't repeat any fields or methods that are inherited and not overridden. So I can actually show you this on in a minute in the next screen. Yeah, so here's kind of this whole diagram of how we can have a bunch of things relate. And before we look at it in detail, let's just talk about the relationship aspect. It is important to understand how things relate. And you can represent inheritance with an arrow. This might seem counterintuitive, because the arrow, you'll notice, is pointing from the subclass back up to the base class, its parent. It's saying, this is where I go to get my fields and methods that I'm inheriting. So it's always pointing toward the base class. And so you can kind of see here, we've got, beverage, and then we've got soda, water, and juice are all subclasses directly of beverage. And then diet soda is a subclass of soda. So all these arrows represent that. And then over here, we've got another inheritance situation where we've got a storage class, and it has a subclass refrigerator that inherits from it. And this relationship here with this diamond is to do with like how many, it's like this is a one-to-many relationship, right? You might have one storage and it's going to have many beverages or other classes that are of the beverage type. And so that little diamond there represents that. This one is one thing, and it can have many of these. So here's to talk about what I was talking about a second ago. Just, storage has this array list of beverages. There's a getter for that. It has a custom toString method. And then it has a couple of instance methods that are add beverages and remove beverage. So when we inherit all of that from storage for refrigerator, we don't need to state all those things again. All we need to do is say anything that's new. So I've got capacity here. We're going to require, and then we actually have to have a constructor that allows you to pass that amount in, because storage only it just uses the default constructor. But here we create one, we pass in capacity, and then we have a getter for that. And then we also are going to have a custom toString for this as well. So You'll notice the same kind of pattern over here. You know, I've only got the things mentioned for soda and water and juice that aren't already in beverage, unless I need to like, unless they're supposed to be overridden, or, you know, slightly different somehow. So that's the general idea. And we can actually look at this. You know, I've used this tool called FigJam. It's part of Figma, one of many great free tools out there. And I've got, you know, all of this diagrammed. And I also went ahead and just diagrammed the main class separately. You don't always do this, but I have some methods that I am actually going to write for this, for storing beverages, refrigerating beverages, drinking beverages. And so I thought it was worthwhile to at least just kind of diagram that, even though you wouldn't necessarily represent it as having any sort of relationship to these directly, because the main method is intended for just, you know, running the entire program. So what we're going to do is we're going to dig in and actually like code a bunch of this out and see how this works with, you know, creating these subclasses from these classes, and then working with creating objects, and then using these methods and seeing how it all fits together. Let me see, I think I have one more bullet point on here. Okay, let's see. Yeah, okay, we're good. So I'll keep this up, but we're going to switch over to the code and kind of go back and forth here. All right. So I've already started a little bit here. I've got a beverage class already started, but I have some things that we want to do to convert it. So as it exists right now, beverage is just a regular class. You can see that right here. And I've set up my structure here in this class 6 package to have a package called beverages, and all of the beverage related classes are going to go here. And then I have a locations package, and the refrigerator and storage classes are in there. And then I've got my main class with, you know, the main method that is outside of those two packages, just inside here. And then of course, for testing down here, I have mirrored, you know, I've done this parallel path of class 6 beverages soda test for that test file. So that's kind of the file structure. And so we're going to be adding more classes to beverage, and then we're going to go over and work in main and start putting some things together. But let's look at it. It is a regular class. It has all of its fields. As you can see, you know, it's got the next ID static field that will always, you know, just hold a new value every time it's incremented with the class. And then each individual instance will have an ID, a name, ounces, what type of container it is, and this Boolean recycled. And we have initialized that to be false. So we're going to add some getters and setters. And because most of these are final, we'll only do getters for those. So I'm going to do the generate. I'm going to say getters, and I'm going to choose ID through container for that and say, okay. So now I have getters for all 4 of those. And then I'm going to do getters and setters for recycled. And the note here says to modify the setter for recycled to print a confirmation to the console if it's true. Excuse me. So, oh, and I forgot the very first thing we're going to do. Let's finish this and we'll go back up. So this one right here, we're going to set it as recycled, but I also want to say, you know, if recycled was true, and we're actually, you know, recycling it, we're going to print a message that just says, you know, and then we'll say this to get the description. I need to concatenate it though. To get the description of it has been recycled. And that'll call our custom toString method that we're going to write in a second. So back up at the top here, I had another to do. It said, convert the beverage class to be abstract. And we do want that because we don't ever want to create a beverage that's just a beverage. We want to make sure that if a beverage is created, it's a juice or it's a soda or it's a diet soda. And so I'm going to put abstract on here, and I accidentally got rid of the class keyword, and that was a problem. Okay. And then when we get down here to toString, it's going to make creating this toString method interesting. First of all, we have to use override. And then we say, public, and normally we might just say, string and toString. And it's going to complain immediately. And okay. It says missing method body or declare abstract. So it tells you, you either have to define it or you have to declare it abstract. So I'm going to add this abstract keyword and then it's happy. Now, if I was to try, on the other hand, to put the abstract keyword in and then try to define it, now it complains. And it says abstract methods cannot have a body. Okay, so this is how this works. You create it just enough to be able to say, I want all of the subclasses of this abstract class to customize this toString method. They have to have it and they have to define it, but I don't define it here. Okay. All right. So now that we've done that, we have a good solid base class. It's abstract, and therefore we need new classes to be able to have other types. So we're going to start easy. I'm going to do the water class because there's very little, if you look here, that is different about water from beverage. Mostly it's just going to be about that toString method. That's going to be, but there aren't even any like new fields or anything. So this is super, super easy. And I will hold, please. Go back to here. Here we go. All right. So we've got this class water. We want to say that it extends beverage. And then immediately it's going to, already it's complaining. And the reason it's complaining, it says class water must either be declared abstract or implement abstract method toString. So it's immediately telling us you have to have toString in here in your definition. So we'll do that. So let's actually just do that first. We'll do an override, and then we're going to say, public string toString. And then I just realized. Oh yeah, it does put it in. Okay, good. Just want to make sure. Okay, and so then we'll, just return our own custom way of, piecing together all the parts of this. And I'm going to paste this in to save time because we have a lot to cover. But again, we're using the super keyword to access, get ounces, which it recognizes here is in the beverage class. So it knows that it has access to it. And then that's it. I just kind of piece all that together. I'm borrowing everything from the parent class, but it's still complaining. So we need to kind of look at that, right? Why is it complaining? And it says there's no default constructor available in beverage. And that's true. Beverage has a defined constructor that has, specific things. So that means that we can't just go without one here. We do actually have to have one. And I can use the generator for that to make it easy, and boom. We have a water constructor that automatically, requires all the same fields that beverage has, and it calls super to pass those into it. All right, anybody got any questions before we do the next one? Okay, cool. So next we will do, let's see, why don't we do juice next? And then we'll get to soda and diet soda in a minute. So back over in my beverages package here, I'm going to create a new class. I'm going to call it juice. And again, I'm going to extend beverage. And it's complaining because we don't have a toString in here yet. So we will go and do this. All right. So something that's a little different about juice, if we go and we look here, this does have its own new field, fruits, which is intended to be an array list of strings. And we're going to say it's final just to prevent it from being overwritten. But it's also private. So yeah, so let's start with that. We're going to have private, final, and then no, array list string, and we'll call it fruits. And we'll just instantiate a new array list, empty, and we'll be good. And then we can create a constructor here. So I'm going to generate a constructor. It automatically pulls in the things that it needs to from beverage. But then, of course, we know that we want also to include fruits. And I'm going to call it fruit array. And I'm actually going to give it the type string array. And the reason for that is because this makes it easy for us to pass a whole bunch of things in at one time. And then what we can do is actually use a special method of the collections class, like this, collections, and yeah, add all. And notice that IntelliJ just imported collections for us. And add all allows us to pass in first the array list that we want it to go into, so fruits. And then we give it the array, and I've got a double comma here. There we go. Then we give it the array that we want for it to pass all of them into. And it adds them all at once. It's super easy. You don't have to loop over anything. It's great. But it's a great way to be able to immediately put things from an array of a fixed size into a collection of variable size. Okay, so that will take care of the constructor for this class. And now we just need to have a getter. Oops, that was not what I meant to do. For the love, okay. A getter for fruits, and it'll return fruits. And then we can have the custom toString method, and I can generate this, but it kind of immediately only says, oh, hey, fruits, right? It doesn't actually recognize that it's got the stuff coming from over from beverage. So I'm going to replace this with this, but I want it to actually like list out all of the fruit stuff, and I'm going to call this fruit list. And so I'm going to use this string builder thing we've seen before, where we, create a string that can be built with like an accumulator pattern. And we go through and every time we hit another fruit in this fruits array list up here, we append that fruit to it. And remember, these are just strings, right? So it's just going to throw that string right on there. And then we're also going to say, if it's something that is in the beginning of the list up to the second to last one, put a comma and a space after it. If it is the second to last one, put a comma, space, and got to use that Oxford comma, guys. And otherwise, it's just going to have appended the fruit, which will be for the very last one. So then it'll just like throw that right in there as part of the string, and we will, get all of that printed out in a nice format. And we're not going to test this just yet because that's going to be a little bit before we get over to our main thing, but bear with me. This will get more interesting once we actually start working with this stuff. But yeah, that's a slightly different example of kind of how you can, extend a class, but then, give it its own flavor, so to speak. Okay, so now we can talk about soda and diet soda. So beverages, here we go. New Java class, soda. And we will extend beverage again. Okay, and for this one, we are going to want an additional field. So we kind of said, yeah, caffeinated is a Boolean. That should be final. And so we'll have private, final, Boolean, caffeinated. And then we can have a, let's see, we just need the constructor, and we'll add caffeinated in, yep, and then a getter for that, and then the toString, yeah. So this is going to be somewhat similar to what we just did. So here I can do the constructor, tell it to add caffeinated, and boom, we've got caffeinated. And then I can tell it to do a getter for caffeinated. We've got that, and then we'll do our toString. And I'm going to actually, for this, just copy this in for the sake of time. But again, you overwrite it, declare the public string to string, and then this one is the one I showed you in the slide where I just am using this ternary expression. Is it caffeinated? If so, set caffeine text to with caffeine. Otherwise, set it to an empty string. And then down here, when we're concatenating it all together, this will either insert with caffeine or it won't insert anything at all, depending. And then we have all of that kind of, reading out. All right, so last one is to do diet soda, and this is where things diverge because we are going to, oops, let's try that again. Okay, diet soda. We're going to actually base this one not on beverage, but on soda, so that it gets that caffeinated field. But we also can take it a step further and add this sweetener field, which is a final string. And then we will have a kind of the same thing here. We just need a constructor, a getter, and a custom toString. So we'll do private final string, capital S, sweetener. And then we will add a constructor. We get the super, which now, of course, because this is extending soda, super requires name, ounces, container, and caffeinated, but we're also adding on sweetener. So that becomes the fifth parameter here. And then we can add the getter for sweetener and then the toString method. And again, I'm going to just copy it for the sake of time. Oops, I don't know what just happened there. That was not what I intended. There we go. Okay, and this will, it looks a lot like the one from soda, but we've added this extra little bit here of sweetened with, and then we use the getter, get sweetener to get that. I mean, I could also just put sweetener here because we are inside the class. It kind of doesn't matter. You could do either one because it's private, but it's perfectly accessible here. Okay. So there's all of our beverages. We have all these different beverage classes. I have already written the storage and refrigerator classes, but I'm going to walk you through them so you understand what they're doing. Storage has a final array list of beverages called beverages, surprisingly. And it does not have a constructor. It's using a default constructor, meaning it can be created without having to pass in any parameters. But we do have a getter here, get beverages, so that we can retrieve that since this is private. And then the toString method, I'm using a string builder here to actually just go through each beverage that's in the array list and append the beverage. And of course, what that's going to do is whatever beverage it is, if it's a soda or a juice or anything it is, it's going to tap into the toString method we wrote for that subclass. And then it'll represent it here as part of this string that it's building. And we'll have a nice list of those. And so then we can kind of do a little bit of logic here so that, it displays something different if there aren't currently any beverages in storage. Otherwise, it'll give us this list. And then here are two instance methods that we said we needed. Add beverages, which is going to allow us to pass in an array of fixed length of beverages, and then use again that collections method add all to say I want my array list beverages to have all of the items that are in the beverage array. And then remove beverage, we're just going to do one at a time. This will be for the purpose of drinking it so that we can remove it from this container. And so we just pass in a single beverage, and then we just use the remove method of the array list class to remove that beverage by just giving it the object itself, which is very handy. Something you can't do in JavaScript, which is pretty cool in Java. So refrigerator is a subclass of storage. We extend storage here. And we give it one more field. We want capacity, so we can say, we only have so much room in our refrigerator for drinks, so we have to kind of limit things, right? So we can limit that by giving this capacity. And then of course I have a getter. And then, here we actually, have a little bit more of a complicated toString because we want to, maybe say something about how much room there is depending on, whether there's still room or whatever. And then we list the contents, or we say there aren't currently any, beverages in the fridge. And that's custom, right? It's a little bit different than what we wrote for the storage class specifically. Now, keep in mind, storage is not abstract. We can create objects of the storage class, and we can also create an object of refrigerator. In this case, it's not really necessary to have an abstract one just to define all this and have, yet another one to define another specific type of storage. If we don't want to, we could just have a generic storage of this class, and that's fine. Okay, so there's, all of those classes that we're going to call from. So let's put it all together. I'm going to take another sip of water. All right. So I've got a note here in our main class up here to simplify the imports from beverages and locations folders. We'll get there in a second because we're going to kind of let it accumulate them as we put things in, and then we'll come up and we'll clean it up. So we want to initialize a storage area and a refrigerator that has the capacity for 4 beverages. This refrigerator is jam-packed, y'all. We have room for 4 beverages and 4 beverages only. Okay, mostly just because I didn't want to instantiate like a billion beverages for the sake of giving this example. Yeah, so they should be stored at the class level, which, as you may remember, means we want to make them static. They also should be protected from being overwritten, so we want to make them final. And we will be able to add and remove things from them, but they themselves cannot be overwritten. So let's take a stab at this. Make sure I'm in the right place here. Okay. So we're going to just say static, final, and storage. And I'm going to call it storage and just say new storage. And remember, this has a default constructor. You don't have to pass anything in. So we're good. Now this is, didn't catch the import. That was probably my fault. I didn't tab over, but I can still hover over it and say, okay, import the class. And now we see it, show up here. Okay. And then static, final. In this case, I'm going to do a refrigerator. And this time I am going to tab over and it automatically puts it up here for us. And then I'm going to call it fridge for short and say new refrigerator. But this requires capacity. IntelliJ is reminding me int capacity. So I need to give it that integer 4. And then we're good. Okay. So these are, I declared these outside of main because I also want to be able to access them for the purposes of these methods down here, these other static methods that we're going to define. How are we doing on time? Let's see. All right, let's do the first one. So we're going to do a whole bunch of things here where we create some beverages and store them and drink them and refrigerate more and all this kind of stuff and see kind of how things unfold. It's going to print nice things for us, but we have to have these methods in order to do that. So we're going to kind of jump down here and write these methods. So this is where it all comes together. Static. This is a void method, and we're going to say store. And it's going to be a beverage array. This will allow us to pass in more than one at a time. And there again, I did not tab over, so, but now it's up there. Cool. Okay. And we have 2 things that we need to do. It takes the argument of the array of beverage arrays. So we need to put it in storage, put them in storage, and then we need to print the contents. So the first thing we can do is call our add beverages method that is a part of the storage class, and then pass in that beverage array. It's really that simple. We've already set this up in a way that makes it easy for us to just pass that along. And then we'll print the storage that we, and this is of course the storage we have created up here that we're going to be manipulating. So that's it. If we want to store stuff, we just pass in an array, and it calls the method of the storage class and passes those in and puts it in the array list that's stored in the storage class. And then we will just print the result, and that uses our custom toString from the storage class. So let's do something similar with refrigerate here. And I'm going to copy and paste this because I want to focus more on stuff we're going to do up in the main method in a second. There's a lot going on here just because I added some logic. So basically, same thing. It takes an array of beverages, but then we loop through them. We don't just like immediately throw them in because we need to check and we need to be paying attention to the capacity, right? So we're going to loop through and do it one at a time. And if the fridge already contains that beverage, we're going to say, hey, that beverage is already in the fridge, and then we don't do anything else and we move on. But if it's not, then we can say, okay, if it's in storage, then we can, definitely move it if there's room. So if the fridge size is currently smaller than the capacity, meaning there's still room, and I'm calling these getters from the fridge class, you can see get beverages and, fridge get capacity. So I'm, comparing the size of that array list with the capacity. If that's true, then we'll remove it from storage using that remove beverage method we wrote in the storage class. I will add beverages to the fridge using the inherited add beverages that it got from storage. And then you'll notice here, what I'm doing is I'm creating I'm just quickly creating a new array, fixed array of beverage type, and then giving it in this case, it's just one beverage, but I'm giving it the beverage in the form of an array, which is what it requires, right? It requires a beverage array. So that's a nice little quick way to do that in line and pass that through it in the right type. And then I'm just printing a little statement, hey, you moved the beverage to the refrigerator. But if it gets to this point and it says, okay, it's not already in the fridge, it is in storage, but there's no more room, then we can print something else and say, hey, there's no more room. And then we're going to break out of the loop, because at that point, it does not matter how many more beverages we're trying to add. It can't take them, right? So we just break out, and then the last thing we do is to print the contents of the fridge. I know that was fast. You could go back and look through this logic later if you would like. For drinking, we're going to kind of do something a little bit similar in a way, except we're only taking one beverage at a time. And we're just going to say, okay, if the fridge has it, then, you enjoy a delicious beverage, and then we remove the beverage from the fridge. So that's no longer part of that list. And then we're going to set the recycled property of beverage to true. Otherwise, we could just print something that says, hey, the beverage is not currently in the refrigerator. And then we'll print the contents of the fridge again, just to kind of give an update. So that's the plan here. We're making use of all of these things we put in place with all these types. Now, something you may have noticed is that I had all of this, it's all in terms of beverages, right? You don't see juice or water or soda or diet soda anywhere in here. And the reason for that is because when you have something that is a base class, you can have an array that has a whole bunch of its subclasses in there and have them all together, and it's fine because they're all ultimately beverages because they inherited everything from the beverage class. So we're going to demonstrate that now. We're going to instantiate 6 new beverages, or 6 or more, I think I'm going to do 7, that are of different subclasses. And so we'll do these one at a time. And let's start with water. And I'm just going to call it, water, and then tab. Water, I was going too fast. And then new water. So I give it the type water, and I also say I want to create a new object of the water class, and I'm going to give it the name water, real original, 32 ounces, and we're going to say it's in a bottle. And that's all that's required for water. It just has those 3 arguments it needs. And then juice, we'll say we have orange juice. And that's going to be a new juice. And this one requires, right? Yeah, I know. Okay, there we go. This one requires orange juice, a name, and it requires ounces and a container, but it also requires an array of fruits. So here again, we can just do this right in place and say new string array, and then use the curly braces to pass in one or more fruits. And in this case, we just have the one orange, which is fine. So we'll pass all of that in, and then we'll do another juice. And this one I'm going to call cranberry, one of my favorites. Cranberry cherry juice. And we'll say that this one is 16 ounces. That's a lot of juice all at once for a diabetic, but let's go with it. And then apple, cranberry, oops, and these are supposed to be individual strings. So let me fix that. Cranberry and cherry. Y'all know those juices are mostly apple juice, right? Okay, and then we'll have, let's see, a couple of sodas. So we'll do soda, Mountain Dew, again with not tabbing, Mountain Dew, AKA battery acid, in my humble opinion. Okay, 12 and something's not right. What have I done? Okay, y'all still with me? Yeah, I must have done something that automatically went to my lock screen. Sorry about that. Okay, I don't know what I did, but I did. Okay, Mountain Dew, ounces. Yeah, I don't know. Let's keep going here. I'll see it in a second. Okay, and it also requires us to say whether it's caffeinated or not. And this, of course, is definitely true for Mountain Dew. We could also have a Sprite. And let's say this one is 20 ounces and it's a bottle and it's false. Okay, so that gives us a couple of those. Now let's do a couple of diet sodas. So diet soda, and we'll do a Coke Zero, one of my favorites. New diet soda, and we'll say Coke Zero, and 20 ounces and bottle, and true, and yes, for a chain. Okay. There we go. And then one more. We'll do Dr. Pepper Zero, also one of my favorites. And let's say this one is just a 12-ounce can. It's true, also the same. Okay. So we've got all of those different subclasses represented here, multiple items. But we can use the store method and add them all at once because ultimately they are all of the abstract class beverage. So I'm going to use storage. Actually, no, I'm just going to call store because store is going to put them in storage. And IntelliJ is reminding me that store takes an array of beverages. So I'm just going to say new beverage array and then list them all in here. So we'll have water, orange juice, cran cherry juice, Mountain Dew, Sprite, Coke Zero, and Dr. Pepper Zero. And all of those can be put into a single array, considered an array of beverages, and that's totally fine because they are all inheriting from beverage. And so we can throw them all in and store it. And so when we do this, we should see, and we can come here and actually run this, we should see this printed out. Yeah, so it added them all and it says currently in storage. And now we can see the result of the two string methods we wrote for all of these subclasses, right? Water is super simple. It just says a 32-ounce bottle of water. Orange juice tells us what type of juice it contains. Same with cranberry cherry juice, tells us, it's containing apple, cranberry, and cherry juice. That's where that fancy, stuff was with, the logic to decide where the commas go and all that. This one, is with caffeine, but this one is without, so it doesn't say that. These both say with caffeine, and they also say sweetened with aspartame. So you get, slightly different results for every single one because each of the subclasses has custom two-string methods that use different fields that belong just to those subclasses. But we can process them all at once because they ultimately inherit from beverage. Okay, so that's great. Now let's put them in the fridge. And you'll notice I've said put 5 beverages in the fridge. There's not going to be room for 5 beverages, but our refrigerate method is set up to handle that, to prevent more than whatever the capacity is. So let's go ahead and do it anyway, though. So we're going to refrigerate, and this will be a new beverage array. And we're going to choose, let's copy this and then, say, we're gonna do, I need to know, let's just take off Coke Zero and Mountain Dew, sure, that's fine. All right, so we'll just pass in those 5 and say we're gonna try to refrigerate those. So let's run it. Okay. So it's telling us you moved the 32-ounce bottle of water to the refrigerator, and it does that, for each of them. But then it gets to the 5th one, and it says there is no more room in the fridge, and it stops. And actually, if we wanted to prove that, it really would stop and not continue to go around and around and around, we could have tried to do more than 5. But we have that break in there, right? That forces it out of the loop once it realizes there's no more room. So it's not going to continue looping through all the beverages, even if we did give it more than 5. Okay, and then we'll try drinking one. And you'll notice that it told us the contents of the refrigerator here too at the end to confirm that those were the ones that exist in there. So now we're going to drink a beverage. So we'll call drink, and we're going to pass in just a beverage. Let's drink the orange juice. We'll see what happens. Yeah, the 10-ounce bottle of orange juice. You enjoy a delicious 10-ounce bottle of orange juice, and then it tells you it's been recycled. And then it lists the contents, and now you can see there's only 3 remaining, and it says there's room for 1 more beverage. So we can refrigerate another beverage. So let's do that. Refrigerate, and let's see. I think one of the ones we took out was Coke Zero, right? Let's do that. All right. Oh, I forgot. This has to be in the form of an array, and it's reminding us of that. So there we go. This is why typing is great, guys. Typing all of your variables, because it keeps you honest on things like that. So you don't try to use a argument the wrong way. Okay, so I moved it, and now the Coke Zero is in the fridge. Now, if I try to drink a beverage that's not in the fridge, which in this case would be the Mountain Dew, looks like. Oh, there we go. Let's see what happens. Yeah, it tells us it's not currently in the refrigerator. And so then the contents of the refrigerator remain the same. And then we can just print the storage contents again to see, hey, what's still left in storage, right? So we can actually just do that directly by printing storage. And it'll call that custom 2-string method we wrote for storage. Yeah, so now it tells us currently in storage is the Mountain Dew and the Dr. Pepper Zero. Neither of which were ever added to anything. Okay, so the last thing to look at here is the test. And so really quickly, I'm gonna run through this. So I've got this, test again down here, test Java class 6 beverages soda test is the file. And I can create hold I can create a quick declaration of objects. So we'll say soda, and I'm using Maven, so I don't have to import the class it already knows. And we'll just say, sure, root beer. And then we'll do another soda, maybe that's, you know, I don't know. Oh my gosh, what's wrong with me? How about Pepsi? Sure, okay. And let's do before. And we'll just do a public void, create test data little method here. And we'll just say root beer equals new soda and give it, you know, root beer. And let's say it's 12 ounces and it's in a can and it's not caffeinated. And that should be it. And then for Pepsi, let's say new soda, Pepsi, 20 and bottle, and true is caffeinated. Okay, and now we can write some tests. And the real point of this is to just have, give me just a second here. Is just to have a way to make sure that your subclasses are actually calling super correctly and instantiating objects that use those fields that were inherited from the parent class, from the base class. So I'm going to actually just, we're short on time, so I'm just going to copy these in. But it's the same idea, you know, name field is inherited, ounces field is inherited, and I just write a spec. A new soda object is given a name through the beverage class constructor. So it makes it very, very clear exactly what we're testing. So I can say it's expected that it's going to be root beer. And so, you know, I check the name and it looks like in this case, I changed my mind on what this is supposed to be. So that's going to be 12. And this is going to be, oh, this is the Pepsi. So that's going to be bottle if it's the Pepsi. Okay, so let's run these tests and just check them and make sure they run. Okay, good. So it confirms that even though the soda class does not explicitly have, you know, name or ounces or container fields, it still does correctly assign them to the objects because of calling super in the constructor and passing those in. Okay, that was a lot, and I know it was a lot. So just keep in mind that in my slides, I always have, you know, lots of links to the code. There's a link to this FigJam here for you guys. And in fact, I'll go ahead and give that to you in a second in the lecture questions channel. But you know, you're going to be able to kind of come back and look at all of this if you'd like. And so let's see. Let's go back to here and just talk about Studio for a second so I can get you guys over there because it's kind of a big one. All right, so you're going to do a quiz. And this is going to be kind of like you've done before. Don't start with the code. Use some way, whatever you want to diagram your classes and design them. You're going to be using inheritance. You want a parent class question, and then subclasses with different question types. And so it kind of talks about, you know, multiple choice, checkbox, true and false. Would be, you know, examples. And then you'll have a quiz class that has a list of questions. And then once you kind of have that all designed, you will have a new Java project that you can code those classes out and then create a quiz runner class with a main method to actually run the program. And you can make that look however you want. But essentially, you're going to be going through the same process I just did with, you know, beverage and all of the subclasses of beverage and storage with a list of beverages, right? And then a main class with a main method. So it's the same type of idea, but you do not have to make it super, super involved. Just cover the basics because this is just Studio. And then I'll come back and run through all of that with you at the end of class. So Since Thursday, we were talking about interfaces and polymorphism. Next Monday, we're talking about Spring. We're going to introduce you to Spring Boot and controllers and routing and all of that for working with Java projects. And then you'll have that catch-up class with that Q&A on Liftoff on Thursday, the 9th. Okay, so let's get you over to here. I will see you guys. Let's see. I want to give you your time back if I can. Let's make it 8:10, 10 after 8. Sound good? Okay. I will see you guys then.